Okay, we've just looked at John and Betty for just our introduction to complex numbers. We're now going to start on our complex numbers booklet. Okay, what we're looking at first is why do we need complex numbers, and we're just looking at some solutions to quadratic equations to see why. So if we want to sketch the quadratic equation y equals x squared minus 5x minus 6 and solve x squared minus 5x minus 6 equals 0, I'm just going to factorise that first. So we've got x squared minus 5x minus 6 equals 0. Factorising, we get x minus 6 times x plus 1 equals 0. Therefore, x is 6 or negative 1. If we sketch that, our roots are negative 1 and 6. It's concave up. It looks like this. Let's just look at the discriminant. Remember, discriminant equals b squared minus 4ac, which is negative 5 squared minus 4 times 1 times negative 6, which is 25 plus 24, which is 29. So notice that the discriminant is positive and it's not a square number, it's just 29. So notice that we've got two solutions, number of real solutions, number of times that the graph cuts the x-axis. Now you've done this in you've done it in year 10 and you've done it in year 11, all right? So now if we look at our next quadratic equation, x squared minus 4x plus 4 equals 0. So we've got x squared minus 4x plus 4 equals 0. If I factorise that, it's 25 plus 24, which is, it is 2, 49. 49, which notice it is a perfect square, which means that your numbers here, your roots are real. No, they're not only real, but they're rational. Rational roots. Rational roots. So that's right. This is a square number. So therefore, yes, we've got, it's positive, which means two real roots. Square number means I've got two rational roots. Remember that?
Is it because they're squared?
It's because, you know, when you've got negative b plus or minus the square root of b squared minus 4ac over 2a, it's got, so we've got negative b plus, so negative 5 plus 49 over 2. Plus square root of 49, which is 7. The discriminant's 49.
Yeah.
So it'll be negative 5. So your roots are x is negative 5 plus or minus the square root of 49 over 2 times 1. So it's negative 5 plus 7 over 2, which is negative 1. Negative 5 minus 7, which is negative 12 over 2. It's negative b, so it's negative 5. So it's 5 plus 7 is 12 over 2 is 6. 5 minus 7 over 2 is negative 1. All good. Okay. Bad start. Let's hope the next one's better. So factorising this next one, we've got x minus 2 squared equals 0. Therefore, we've got x equals 2. But that's a double root. How do we know it's double root? It's a quadratic equation. X squared, you're supposed to have two solutions to a quadratic equation. So this is concave up. We know that it just bounces off at 2. What's the y-intercept, by the way? Anyone? When x is 0, what's y? Okay, so this graph looks like that. The discriminant is b squared minus 4ac, which is negative 4 squared minus 4 times 1 times 4, which is 16 minus 16 is 0. So therefore, if you were to do roots using quadratic formula, wouldn't you get x is negative 4, which is 4, plus or minus the square root of 0 over 2 times 1. That's why you've just got 4 over 2. So 1, if your discriminant's 0, you've got one real root, and it will be rational as well. Okay? This factorisation, it's a perfect square. What two numbers multiply to give positive 4 but add up to give negative 4? And it's negative 2 and negative 2. So that's the factorisation of that. That's what that looks like. So notice, if the discriminant's positive, you've got two roots. If it's a square number, the roots are rational. If the discriminant is 0, you'll only have one root, one real root. That's what this all means. It cuts the x-axis once. Let's look at this next one here. It says sketch this quadratic equation. Now, can we find two numbers that multiply to give 2 but add up to give 1? No, well, any two numbers that multiply to give 2 are 2 and 1, or negative 2 and negative 1. They are the only two numbers, or we can try the quadratic formula, all right? But two numbers that multiply to give 2 are 2 and 1, so, or negative 2 and negative 1. If you add them up, you get 3. Or if you add up negative 2 and negative 1, you get negative 3. This doesn't look like it can be factorised, okay? So, x squared plus x plus 2 cannot be factorised. I'll just put cannot be factorised, but let's look at the discriminant and see why, okay? Actually, how else can we sketch that? So we can't factorise it. How can we sketch it? Can you tell me the y-intercept? Good. When x is, I don't know, can you tell me the axis of symmetry? Axis of symmetry. X is negative b on 2a, which is negative 1 over 2 times 1, so it's negative a half. It occurs at negative a half. Now, when x is negative a half, what is the y value? So when x is negative a half, y is, what's negative a half squared? A quarter plus negative a half, which is minus a half plus 2. Well, girls, it's 2 minus a half is 1 1/2 plus a quarter, it's 1 3/4. So where is that axis of symmetry? It's at negative a half, 1 3/4 is about there. It's concave up. The graph actually looks like this. Now, that's what the graph looks like. If you plot points, but you don't need to plot points, you'd never, now at this stage, you don't plot points. You do y-intercept. If you can't factorise it, you do the vertex. Now the vertex is negative a half, 1 3/4. We can see that there are no real roots. Number of real solutions. The number of times that the graph cuts the x-axis is 0. Let's see why. The discriminant, b squared minus 4ac, is 1 squared minus 4 times 1 times 2, which is negative what? Negative 7. That's why if I'm doing x equals negative b, which is negative 1, plus or minus the square root of b squared minus 4ac, which is negative 7, over 2a, which is 2, you can see that there's no solution. Okay? Now this is why we need, you know how we say there are no real roots? What we're doing here is complex numbers and imaginary numbers. We do have imaginary roots. Okay? So there's no real roots, however we do have imaginary solutions. And that's what we're going to look at now. Okay? That's why we need complex numbers. For a root to be real, for a quadratic equation, the graph has to cut through the x-axis. Now, the graph does not cut through the x-axis here in the last one. So we say no real roots. You know how you've been saying that all of year 11? You've been writing no real roots. It just means that the graph does not cut through the x-axis. So what we're going to do, we're going to work out what the imaginary roots are. All right? Because we know that I squared is negative 1. So we're going to work with that in a minute. All right? You'll see it in a minute. So over the page, consider the quadratic equation x squared plus 1 equals 0 and try to solve it. Look, if you sketch it, you're supposed to be sketching y equals x squared plus 1. Okay? That's what you do to sketch it. You sketch that bit and you see if it does ever equal 0. Now, y equals x squared is a concave up parabola like that. Y equals x squared plus 1 is just y equals x squared shifted. Where? Up 1. So we know that this is y equals x squared plus 1. Can you see that that's got no real solutions? Now, we can do it that way. We can sketch y equals x squared plus 1 by sketching y equals x squared down here and then shifting it up 1 unit. And we can see that there's no real solution because it doesn't cut the x-axis. If we look at those previous 3 examples, we know that there's real solutions when your parabola cuts through the x-axis. We know that this doesn't. The other way you could have done this is go x squared equals what? Negative 1. That has no solution, or no real solution anyway. So no solution, okay? So we can see it's got no solution like that, and we can also see by sketching that it has no real solution. So no real solution, however, this equation can be solved by means of an imaginary number, I, defined as follows. I squared equals negative 1, or if you square root both sides, the square root of I I squared is -1, or if I square root both sides, what do I get? So can you fix that? If I square root both sides, what do I get? I is, no, square root both sides. That's it. Thank you. Okay, so I squared equals -1, or I equals the square root of -1. Typo. Okay, fixed it. Liquid paper it. Do whatever you have to do. And then highlight. So what we're now going to do is we're going to solve this same quadratic equation that we tried to solve before using the fact that I squared equals -1. So let's start again. We've got x squared plus 1 is 0. Now, which means that I can do this a few ways. I can go, well, x squared is -1. But I know that I squared is -1. So therefore, x squared equals, what can I replace the -1 with? I squared. I'm going to do this two ways, okay? So therefore, x squared equals I squared. I can then take everything over to the left and factorise if I want, or I can just go x is plus or minus the square root. You know, if I've got x squared equals 25, doesn't x equal plus or minus the square root of 25, which is 5? Okay, so if x squared is I squared, then x is plus or minus the square root of I squared, which is plus or minus I. Now, I'm going to do it another way. I don't like doing it that way. All right? So the other way I'm going to do it is as follows. Or I can do it as follows. X squared plus 1 equals 0. You know, girls, you know how to solve the following? Look over here. A squared minus b squared is 0. That's called the difference of two squares. How do you factorise that? A plus b times a minus b is 0. Therefore, a equals b, or, therefore a plus b is 0, or a minus b is 0. Remember that, right? So therefore a is -b, or a is b, right? We're going to use that idea. So, see, this isn't a difference of two squares that I can see. It's a sum of two squares, because x squared plus 1 is x squared plus 1 squared. So I'm going to make it a difference of two squares and write x squared minus -1 equals 0, right? Isn't x squared plus 1 the same as x squared minus -1? It is. Two minuses make a plus. So therefore, x squared minus, I'm going to replace this -1 with what? So x squared minus I squared equals 0. Now factorise. X plus I, x minus I equals 0. Okay? So therefore x is what? X is I, or x equals minus I. For the first one, x would be minus I. For the second one, x is I. I don't want to write x plus I is 0, therefore x is -I. All right? So now we're going to get into some questions here. Okay, it says, next question. So we're going to use this idea now. Solve the quadratic equation x squared minus 4x plus 13 equals 0. Girls, we're going to need to work in two columns here. Using the quadratic formula and the fact that I squared equals -1, then we're going to sketch the curve. So here we go. X equals -b. So we're using the quadratic formula. -b is 4. -4. Plus or minus the square root of b squared is what? 16. Minus 4 times 1 times 13 over 2 times 1. So therefore x equals 4 plus or minus the square root of what? 16 minus 52 is what? Negative? -36 over 2. Now, of course we can't do the square root of -36, but we can change our, remember that's -1 times 36, so it's 4 plus or minus the square root of 36 times -1, which is 36 times I squared. 36 I squared? Yes. Because I squared is -1. Over 2. Now girls, you can now square root 36 and you can square root I squared. So that's 4 plus or minus what? What's the square root of 36I squared? 6I over 2. So now we've got two solutions. Actually, what can we do with all of this? Girls, notice the 4 is even, the 6 is even, and 2 is even.
2 plus or minus 3i.
That's right. You divide by 2, divide by 2, divide by 2. You're basically dividing the numerator and the denominator by 2, and you get 2 plus or minus 3i. In other words, we've got two solutions, 2 plus 3i, 2 minus 3i. So they're my two solutions, 2 plus 3i, 2 minus 3i. You can write them side by side, or you can write it as 2 plus or minus 3i. That's the same thing as saying that. So if I actually want to sketch this graph, we know, because the discriminant's negative 36, that there are no real roots. So it's not going to cut through here. I can't factorise it. But, all right, tell me what the y-intercept is. Remember, if it doesn't have any if it doesn't cut through the x-axis, you can't factorise it. So remember the other thing we did on the page before? How did we find where it turns? How did we find the vertex? And we found the y-intercept. All right, axis of symmetry. So axis of symmetry is x is negative b over 2a, because I'm asking you to sketch the graph, okay? Negative b on 2a is negative 4. It's 4 over 2 times 1, so it's 2. And when x is 2, what's y? Let's just look at it here. When x is 2, we've got 4 minus 8 plus 13. Y is 9. So is it concave up or down, girls, the graph?
Up.
It's concave up. Y-intercept is? What's
13.
the 13? Axis of symmetry is 2, 9. Just a quick sketch. Looks like this. That's the curve. That's why there are no real roots. And it's got imaginary roots. Now, so one way of working out the root to solve this quadratic equation, we used to stop here at 4 plus or minus negative 36 over 2 and say no real solution in 2 unit. Now we go further and we work out the complex or the complex solutions, okay? So we say, no, we don't need to stop there. That's 36i squared, and we can give the two imaginary or complex solutions. Okay, so now we can solve any quadratic equation and don't need to say no real solution. Even though there are no real solutions, there are imaginary solutions. So another way you can solve quadratic equations, girls, apart from factorising and using the quadratic formula, is to complete the square. So we're going to solve and get our imaginary solutions exactly the same question, again now by completing the square. So let's start. X squared minus 4x plus 13 equals 0. Do you remember how we complete the square? What do you do with that 13? Yeah, take it to the other side. X squared minus 4x equals negative 13. And then don't we do half the b and square it and add it to both sides? Do you remember that? So we've got x squared minus 4x plus, what's half of the b? Well, it's 2. So we go 2 squared. Yeah, I like to leave it as 2 squared because I then write it as x minus 2 squared equals negative 13 plus 4 is negative 9. Now we know that, do you remember the next step from here? We've got to get rid of the squared. What's the inverse operation of squaring? Square rooting. So therefore x minus 2 is plus or minus the square root of negative 9. Whenever you square root both sides, you must do plus or minus of the side that doesn't have the x on it. Okay? So it's plus or minus the square root of 9, but we don't have to stop there now because square root of negative 9 doesn't stop us now. We replace that with 9 what? Negative 1 is I squared, so it's 9i squared. So therefore x minus 2 is plus or minus, what's the square root of 9i squared? 3i. So therefore x equals, the negative 2, bring it to the front. Bring the negative 2 to the front. What do you get? 2 plus or minus 3i. You don't stick it at the back and write plus or minus 3i plus 2. You bring it to the front. You're adding, inverse operation of minus 2 is plus 2. 2 plus or minus 3i, same solution. by completing the square. When you do this step, square root of -9, and then you go to the next step here, you should always write since I squared equals -1. So can we add that in? Forgot about that. Okay, and up here as well, as I squared equals -1. So whenever we introduce that, because it's, you know, something that's assumed, as I squared equals -1. All right? Now, any number of this form, a plus bi, notice that a and b are real. So, for example, a here is 2 and b is 3. But you've got an imaginary part with one of them. You've got a real bit, which is the 2, and the imaginary bit, which is the 3i. So any number of the form a plus bi, where a and b are real numbers, is called a complex number. So, for example, 2 plus 3i and 2 minus 3i, those two numbers above, are complex numbers. Okay? To solve these equations using the quadratic formula and completing the square. So we've got x is -b. Plus or minus the square root of b squared, which is 4, minus 4 times 1 times 3 over 2 times 1. So it's -2 plus or minus the square root of 4 minus 12 is -8 over 2, which is -2 plus or minus the square root of 8i squared over 2, as I squared is -1, which is -2 plus or minus root 8i over 2. Now, root 8i can be written as root 4 times root 2, which is 2 root 2. So we've got -2 plus or minus 2 root 2i. So we were able to square root the I squared and get I, but I kept it as the square root of 8. Square root of 8, remember, is 2 root 2. It's the simplified surd. So now all of these are even. Looking at the whole numbers in front, we can divide numerator and denominator both by 2, and we get -1 plus or minus root 2i. So therefore, your two solutions are -1 plus root 2i, -1 minus root 2i. Quadratic equation by completing the square, x squared plus 2x plus 3 equals 0. So therefore, x squared plus 2x equals -3. Completing the square, half of 2 is 1, so we're adding 1 squared to both sides. So therefore we've got, writing this as a perfect square, we've got x plus 1 all squared equals -3 plus 1, which is -2. Now square rooting both sides, we've got x plus 1 equals plus or minus the square root of -2. We now write the square root of -2 as -2i, sorry, no negative anymore, 2i squared, since I squared equals -1. I'm going to bring that 1 over as well, so therefore x equals -1 plus or minus the square root of 2 can't be simplified, but the square root of I squared is I. So you've got square root of 2 and the I is not under the square root sign. Got it? So therefore your two solutions are -1 plus root 2i, -1 minus root 2i, which are the same solutions as what we got up there. So that's just two ways of solving a quadratic equation and writing the roots as complex roots. Okay?